Hey guys, so in this question, you have a field function being given. The electrostatic field function is given as 2ax I cap plus a into x squared minus y squared j cap. From this electrostatic field function, we now need to calculate what your potential function will be equal to. How will potential vary as a function of x comma y? So this is a standard question based on relation between field and potential with a slight mathematical aspect to it. So let's look at how we'll be solving this kind of question, right? Okay, so generally when we have field being given and we need to calculate potential, the idea we'll be going ahead with is we'll write down dv is equal to minus e bar to dr bar. But this idea has a slight drawback in this case, as you'll notice right now. Okay, so what is dv equal to? Now I can write dv is equal to minus e bar dot dr bar, so that will be equal to minus 2ax by dx plus a of x squared minus y squared into dy, right? And now to find out change in potential, I can assume potential at origin is some reference. Then to find out change in potential, I have to do integral dv. So how do I integrate this function is basically what will lead to a mathematical complexity over here, right? So to avoid this mathematical complexity, we'll be looking at another way of solving this question. You can still solve it from here if your max is better, but right now we'll be looking at another way of solving this. And the other way of solving this is by using the other formula of relation between field and potential, which is Ex is equal to minus dou v by dou x, Ey is equal to minus dou v by dou y. Okay, so let me go ahead with this. So let me assume your potential to be a function of x comma y, and I know potential will be a function of x comma y over here because your electric field also varies only with x and y. Okay, so then can I write minus dou v by dou x is equal to your x component of field, which according to this question is 2axy, right? So from this, what will potential be equal to? It will be equal to minus 2axy into dx, or should I write dou x, indicating that now I just need to integrate this with respect to x, keeping a and y constants, keeping all terms of y constants as well, because we got this by partially differentiating v with respect to x. So when I'm going the other way around, that is when I'm integrating it, I'll have to keep all terms of y constant and I'll have to integrate this with respect to x only. Okay, so performing this integration, so as I mentioned, a and y will be constants right now. So this will be integral x dx, and integral x dx is nothing but x squared by 2, right? So you'll get potential to be equal to minus 2a of x squared by 2. And now one more thing to realize over here is this was an integration without any limits. So you'll have an integration constant over here. And now because you're doing a partial integration with respect to x, your integration constant over here will be some function of y. Because if you remember, any function of y will be treated as a constant when you're partially differentiating with respect to x. So the same idea here is carried forward in integration as well. Your integration constant here will be some function of y, right? So we partially got v as a function of x comma y. We are getting v as a function of x comma y to be equal to minus ax squared y plus some function of y. Okay, now moving on to the next step. The next step is implementing the other component, right? So to implement the other component, let me integrate this once again. So minus dou v by dou y is equal to y component of electric field, which is equal to a of x squared minus y squared. So what is minus dou v by dou y? So minus dou v by dou y is nothing but minus dou by dou y of, I already found v partially, so let me substitute that. It is minus ax squared y plus f of y, right? And this will turn out to be nothing but ax squared plus f dash of y. And this is f dash of y because when I'm partially differentiating a function of y with respect to y, everything is a term of y over here, so this will just differentiate like a normal function of y expression. So ax squared plus f dash of y is equal to nothing but a of x squared minus y squared, which means my function of y in this case, my f dash of y in this case, will be equal to minus ay squared. So df by dy is equal to minus ay squared. So what will f of y be equal to? F of y will be equal to minus ay cubed by 3. And now again we got this from integration, and this integration is performed without limits. So in your function of y you'll have some constant, and this constant will be a constant c only because every function of y is taken care of in this portion. Now every function of x is taken care of in this portion, and every function of y is taken care of in this portion. So from this, we now found out what f of y is, which was your unknown term in your potential function. So now what will be potential as a function of x comma y? Now I can write down potential as a function of x comma y is nothing but minus ax squared y plus minus ay cube. Okay, so this is f of y was plus ay squared, this will be ay cube plus ay cube, I see. So it will be plus ay cube by 3 plus some constant. So this will be a potential as a function of x comma y. Right, hopefully the solution made sense. So this will give me which answer? This will give me the third option. The third option will be an answer for this question, right? So hopefully this question made sense. See you in the next question.